Assalamualaikum and hi everyone. In this video, I'm going to discuss about high pass filter, the circuit of high pass filter and also the equation of high pass filter. This is the circuit for high pass filter. It looks very similar to low pass filter, but the difference is at the position of the resistor and capacitor. You can see here that the voltage input will go through the capacitor and then only go to the resistor to the ground. So how this high pass filter work? So this high pass filter will work by filter by block or attenuate any signal that having frequency lower than cutoff frequency. If the frequency is higher than cutoff frequency, then the signal will be passes through. Okay, let's derive the equation for high pass filter. Similarly, we're going to use the voltage divider circuit, which is the equation is Z2 over Z1 plus Z2 V in. So in this case, we have ZC here and ZR here, where we do know that ZC is equivalent to 1 over CD and CS equivalent to 1 over Cj omega, and also can be written in form of frequency J 2 pi Fc. While for ZR, the impedance value is R. So putting the impedance value into a voltage divider circuit will give us R over R plus 1 over J 2 pi Fc multiply with V in. So if we simplify this equation, we can write V out over V in is equivalent to J 2 pi F RC divided by 1 plus J 2 pi F RC. So from this equation, we are also able to get the gain or the voltage output per voltage input ratio in magnitude will equivalent to 2 pi F RC over square root 1 plus 2 pi F RC square. The derivation that we did give us the output to input voltage ratio at any frequency, meaning for a specific C and R here, we will be able to determine the V out over V in by putting the frequency value here. So as we already know that Fc is a characteristic that will determine the behavior of our filter. So Fc can be designed by choosing a suitable value of R and C here. So in order to normalize this equation, we replace Fc into this equation so that we get equation number 2 here, which is the output to input voltage ratio normalized to Fc. For example, if we consider F is equivalent to Fc, then F over Fc is equal to 1. So putting that equation, we get the gain will be equivalent to 1 over square root 2, which is equivalent to 0.707. So meaning at frequency equivalent to cutoff frequency, the signal will be attenuated or will be blocked by around 30%. Only 70.7% will be allowed to pass through the filter. This is the response of the high pass RC filter as a function of frequency ratio. So this is our frequency ratio, F over FC, as we have calculated before. When F equal to FC, F over FC is equivalent to 1. So here, where our calculation said it is around 0.707. So this is the location. So what does this location tell us? It means that the filter will be blocked around 30% of the signal. Only 70% of the signal pass. Okay. Here, this is the location for F smaller than FC. It is around 10 times smaller than FC. We can see that the gain is around 0.1, meaning the filter will only pass 10% of the signal and block 90% of the signal. At this region, here is frequency higher than cutoff frequency. Here it is 10 times higher than cutoff frequency. The gain is 1, meaning it will 100% pass the signal. So this behavior explains the response of the filter based on the frequency ratio.